Hello everyone, my name is Dipankar Abhishek and I'm a mechanical student of GIMS Engineering College, and in this video I would like to introduce machine learning to you and its application in real-time world. Before I directly start with the project, I would like to introduce you with some of the terms that are artificial intelligence, machine learning and deep learning. To understand these three terms, we can compare these three with our nervous system. Just like when there is any kind of disturbance in any part of the body, the neural network transmits the information to the brain. So this is what deep learning is. And what is machine learning? It is just the capability of a machine to recognize and predict what kind of disturbance it is, whether you are touching a hot or a cold object, or whether you are being attacked. On the other hand, when you provide a decision-making capability to a machine, it becomes the part of artificial intelligence. Just like you realize it is a hot plate and now you have to remove your hand. So of course this is central intelligence, but in case of machine it is artificial intelligence. So this project involves the application of machine learning and computer vision, and I have already explained what machine learning is, and now in the upcoming slides we will be discussing different types of machine learning. So we have three different categories. First is supervised learning, second is unsupervised learning, and third is reinforcement learning. So for better understanding, I will be explaining these terms in a simple words rather than in a mathematical expression. Coming to our first type, that is supervised learning. In this, algorithm learns the input pattern that generates the expected output, and once the algorithm is trained, it predicts the never seen input. For example, here you can see that the algorithm was taught several times that for this particular structure it should be a duck and otherwise it should not be a duck, and then a never seen input was given and it predicted it as a duck. So the application of supervised learning can be a biometric security. You might have seen in your mobile phones while setting up a fingerprint security, you provide your fingerprint several times. So this way the machine learns that this is an authorized fingerprint, and if someone else tries to unlock it, then the permission is denied. So now coming to our next type, that is unsupervised learning. In this kind of approach, the data instances of a training dataset doesn't have any expected output associated with them. The unsupervised learning algorithm detects the pattern based on the character of the data. I mean, similar data based on the characteristics and structure are grouped together in a same category, but the algorithm doesn't have the ability of labeling it. It is just like you are going to a party where you don't know anyone, but you start grouping the people without any prior knowledge about them. The grouping can be on the basis of gender, behavior, age, etc. Here is an example of unsupervised learning. Here in this case, the search behavior of the user is observed and then the products are recommended to the user. Like if the user search laptop, then the pendrive will be recommended along with the other electronic devices. Coming to the last type, that is reinforcement learning. I would like to explain this directly with an example. So here you can see that there are two images. One is bunny and the other is duck. So what happens is, first the machine observes the environment and then the machine executes an action based on some policies. And if it makes the correct decision, it gets reward points, and if it predicts the wrong output, then the penalty is applied. The machine is trained several times until an optimal policy is achieved. Once the training is done, now it can easily identify the input to give correct output. Here we have an example of reinforcement learning. This is not a practical example, but this will give you a complete picture of what reinforcement learning is. Here in the first case, the food was given to the dog, and the next day the owner rang the bell but no response was given by the dog. Then in the third case, the owner rang the bell and put the food. This was done several times. Now the dog upgraded the policy that whenever there is a ringing bell, there is a food. Now in the fourth case, the owner rang the bell and dog itself came to eat the food. So this is exactly what reinforcement learning is. And now coming to the practical example of reinforcement learning, so it can be observed in the banking sector, where the bank proposes several offers to their customer. Now they will analyze the data using machine learning algorithm, that how many users accepted the offer, and if they observe that the customer didn't respond well, then the bank will upgrade their policy and will propose some different offer. This was an overview on machine learning. Now I will be showing you a practical project on machine learning. There are various other projects on machine learning like Boston House price prediction, but we will be seeing a pipe detection project. Coming to a pipe detection project, so there are various approaches for pipe detection. One of them I am presenting here. In the first step, we convert a particular image into a black and white image so that we can obtain the boundaries of all the objects that are present in the image. Then 20 by 20 patches are generated using an algorithm, and then the model is trained using those patches. Hence the algorithm is able to predict the desirable object in a particular image. So this is the algorithm that has generated these patches. There is one more set of algorithm that is actually responsible for detection of pipe, but due to some restrictions it is not shown here. So whenever that algorithm encounters the top two images, the count should increase by 1, and for bottom two patches, the count should not increase. Of course, these are just 4 patches, there are millions of patches generated, and for each patch you have to define that the count should increase by 1 or not. So in machine learning project, observing how the model is behaving with time is must. For this we kept on observing two graphs. First one is model loss graph and the second one is model accuracy graph. In case of accuracy graph, the ideal curve should be same as that of blue curve, but the practical curve that was generated was almost overlapping it. Whereas in the case of model loss graph, the ideal curve should be same as that of blue curve, but you can see the observed curve is very random in nature. For some cases, it even came below the ideal curve, whereas it even had 100% losses. But the graph was plotted by using 23,000 patches. If the patches were around 1 to 2 million, then the curve won't have been much random in nature. You can even see that it was getting in shape at the end. In machine learning projects, there is one more important factor, that is accuracy. High accuracy can be achieved by providing more data, but the 100% of accuracy cannot be achieved. 0.01% of the losses are common. Now I would like to conclude the presentation with a small message. Thanks everyone.